Hi there folks, and welcome back to the Tower Tech. This is my new series that's going to teach you in 7 parts how to water cool a PC. The 7 parts are going to be this video, which is an intro and an explanation on how you purchase and plan the components that you're going to buy. The second part is going to be all about fitting radiators and the different configurations for fans, push, pull and push-pull. Don't worry too much if you don't know what that means. The third is going to be all about fitting GPU water blocks. That's one of the more interesting and more challenging opportunities for water cooling, so warrants a video on its own. The fourth is going to be all about mounting a CPU water block. The 5th chapter is going to be about mounting your pump and your reservoir. The 6th chapter is going to be about doing tubing, both hardline and soft tubing. We'll be doing hardline tubing in this build, but I will cover both. And the piece de resistance, the final chapter, the 7th, is going to be filling and priming the system itself. So make sure you're subscribed, otherwise you run the risk of missing some of that great content. And tick the little bell icon as well so that you know when I upload one of these videos. Water cooling is definitely easier than you think. All of the parts that are available commercially are all designed to work together and will definitely debunk some myths and help you simplify the whole process, get away from horrible spec sheets and just enjoy the pleasure of actually building. The key to this is research, 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 which I guess you already know, which is why you're here watching this video. So firstly, a bit of background on water cooling. Those that are familiar with building PCs, and hopefully you are if you're looking at advanced tutorials like this, will know that typically we use heat sinks to dissipate heat away from hot components like the CPU and GPU out into the atmosphere. Water cooling essentially works in exactly the same way, except it uses water to move that heat away from quite small components into a space that we can fit a much larger heatsink, or radiator as we would call it in water cooling. Water is substantially more efficient at moving heat than water. If you're interested in that in more detail, then please click the link here where you can see one of my earlier videos that talks about this in some detail. Primarily, we use water cooling to achieve 2 things. One is an ultra quiet system. We can run much larger fans at much slower revolutions per minute, which allows for much quieter systems. And because of the improved thermal capacity of water, it allows for greater overclocking potential as well. So selecting your components, again, do some research. Components, particularly for CPUs and GPUs, are typically designed specifically for the parts that you've got. So if you've got an Intel CPU, then you're going to want a CPU block that is designed to fit the particular socket that you have, and there is a myriad of different sockets available. If you've got an AMD Ryzen build, the AM4 socket, which is much newer, you need to find yourself a CPU block that's designed for that, or you can buy yourself a specific mounting bracket that will fit on most EK Water Blocks CPU blocks. There are configuration tools available that can help you do this. EK Water Blocks has got a great configuration tool on its website, and it's absolutely ideal for beginners. The watch out is it tends to add lots of components and tools that you don't actually need, which starts to bunk the price up and can put some people off. It's really important that you purchase a case that's got sufficient room for water cooling within it. Most MIDI towers do have sufficient room in them, but a quick glance over the manufacturer's website will quickly reveal whether or not they've got room. And a quick Google actually as well, guys. You can normally find examples, pictures, blogs, etc. of people that have built in these cases, and that normally confirms whether you've got the space to do it and also starts to give you an idea of how your loop is going to work. You need space to mount your reservoirs, you need space to mount your pumps, and you need space to mount your radiators. Radiators need to match the size of the case that you've got, and typically that's by the fans that you have, either from an intake or from an exhaust perspective. This particular case has got 120mm fans, 3 at the front, 2 at the top, 1 at the back. So you want to purchase radiators that are going to fit that fan configuration. Typical fan sizes are 120mm and 140mm, and again, you can check this quite easily on the manufacturer's website. There's lots of complicated thermal properties that you can research. You can read all about the amount of heat that's typically being generated from your CPU and your GPU, and most radiators come with a specification that talks about the amount of heat that it can dissipate. If you feel so inclined, by all means, feel free to do those calculations. A simple rule of thumb is you need one 120mm spacing on a radiator for each hot component that you're cooling, and 2 if you plan to overclock that component. So for a CPU and GPU at stock speeds, a dual 120mm radiator is sufficient. If you plan to overclock those components, you need twice this. So either 2 of these radiators or a quad 120mm radiator. There are different thicknesses of radiators available. Typically, the overall surface area from a side perspective, as I've got this held here, is more important than the actual thickness of the radiator. Typically, I go for the thickest radiator that I can get. Quite often, I find myself going for quite thin radiators because I want a nice compact build. I've got a steel ruler that I find absolutely invaluable for measuring the space between components and the fans to make sure they fit before I order them. It's a tried and tested routine. I know the exact width of that metal ruler, and if the parts do or don't fit, then it makes it really easy to select them, and then I don't have to return things later on, which is quite frustrating. And radiators have a particular fin density on them. That's typically measured in fins per inch. The higher the number of fins that you have per inch, the greater the cooling capacity of that radiator, should I say, is going to be. But it does mean that you're going to generate more noise. As the fans are pushing air through the radiator, it's going to create a lot of turbulence if you've got high fin density, and that's going to create a lot of noise. Typically, what I would recommend is for smaller and thinner fans, go for a higher fin density, somewhere around 22 fins per inch. And if you've got much larger and much thicker radiators, go for a much lower fin density, around 10 fins per inch. The radiators do normally need to be flushed. I've got a video that shows you how to do that in detail. Again, hit that button just up there. You can buy all sorts of cleaning solutions, but actually a bit of distilled water and a bit of white vinegar really does the job. Just make sure that you do a thorough flush through with plain distilled water. Otherwise, if you leave vinegar in there, it is going to corrode your radiator over time. Whatever you do, don't use normal tap water. It's got all sorts of minerals and rubbish in there that is going to cause you problems much later on. In terms of fans, I recommend using static pressure fans where you can get hold of them. Normal airflow fans, like you would get on your case, will allow air to actually slip around the radiator and don't actually push the air through, which means that you don't get the same kind of cooling capacity. Static pressure fans are actually designed to channel that air and force it through the fins, maximizing the cooling potential. When you buy water blocks, make sure you get them from a well-known brand like EK Water Blocks or XSPC. It's not worth scrimping. Anything that's got a seal in it is typically where you're going to get a leak, so making sure that you spend a reasonable amount of money, typically you get what you pay for, is going to save you a lot of headache in the future. Most blocks are generic, however GPU blocks are very specific to the board that you have. There are lots of differing board designs, add-in board partners that manufacture on behalf of both AMD and NVIDIA. So I recommend going to the manufacturer's website of the water block and actually checking the compatibility with the specific card that you have. Buying a Founders Edition water block and trying to fit it on an Acer Strix card is not going to work. Not only is the board a different size, but the layout of the components is very, very different as well. In terms of pump and reservoir, again, there's lots of complicated stats that you can get into, flow rate, head pressure, etc. I suggest that you ignore all of that and just buy yourself a D5 pump with a reservoir combination and don't worry about PWM. Doesn't matter if you have got it, doesn't matter if you haven't got it. We'll cover that in a later video. You can't go wrong with the D5 pump. It has great head pressure, which is the most important statistic that you need, but don't get hung up on that. If you go with the D5, you'll be absolutely fine. From a tubing perspective, as we previously said, there's soft and hard tubing available. Soft tubing is much easier to work with, but in my opinion, and many others, it doesn't look as good and as clean. Hard tubing requires different types of fittings that typically are more expensive, and you have to bend the tubing in order to get it maneuvered around your case, and that's quite an advanced process and can be quite tricky to do. There's different sizes for both, and these are typically listed in terms of inner and outer diameters. If you're going for hard tubing, I do recommend you go for PETG. It's much easier to work with than acrylic, and it's far less brittle. It has a little bit of flex in it, and it's typically a bit easier to bend as well. You're going to need to purchase a tube cutter irrespective of the type of tubing that you go for. Again, if you're interested in a more detailed video on bending and cutting PETG tubing, then click the link there, but we will cover it as part of this series. For your fittings, again, make sure that you buy from a reputable brand. This is typically the most common place that you're going to find leaks, all of those O-rings, and particularly where you've got twist complicated fittings, you can quite often find leaks within those. Personally, I buy the compression fittings up front. That's pretty easy to do. Typically, you count up the number of components that you've got tubing going into and double it. Normally, they need 2 fittings per component. But for things like 90-degree bends, I normally wait until I've got all the components and I'm actually starting to fit out the system. If you guess, you either end up short or you end up spending too much money. This isn't a build that you're going to do in a day or two anyway. You know, take your time, get it right, and be okay with ordering the fittings whilst you're mid-build. So there we go, guys. A quick intro to my water cooling series. I hope you're really well wherever in the world you are. Please like and share this video, and I'll see you in my next one.